So if you guys are first time here, welcome. I'm David, the director of Guided Surgery Division in RealGUIDE Dental Lab, and I'm also the is a speaker for co-diagnostics and software RealGUIDE, and then I'm also the one of the KOL for DAS Guided Surgical Kit. So before we start on those, whatever advanced, guided surgery, what we have to do is always is actually start from here, like a little lobby, and was introduced by this awesome guided surgery pioneer in our industry. And then he wrote a book about guided surgery, and this book just how I get in the field. So this book is actually translated to Chinese and has to be published in China also. And then that doctor to do that thing is actually the one to bring the guided surgery technology back in China. And then he actually just being I am so privileged to he's actually my mentor. He's the one to bring me into this field. And then I actually studied the guided surgery not from the back of the computer but by chairside as a surgical assistant. And then he just built digital lab in the office chairside. So he bought 3D printer, and the guided surgery software and even dynamic guided system. So I was able to see and work with all this amazing technology. And then I was so fascinated by all these. And then a couple years ago, I moved to California in the US, and then I'm working in the pretty big lab, and then running, as a surgical planning specialist. And that's where I met my current mentor, Dr. Brandon Cover. And then he brought me here to North Carolina, working with him. He's a board certified prosthodontist, and then he also actually owned a dental lab, which is, I was, very fortunate to being able to work with this amazing people together. So that was so good. And then today we're gonna, and then also I was, able to work with those, Dr. Kofer, Dr. Lim, and Dr. Camino very closely. So even though I'm a lab tech, but actually I work with them basically day by day. So I was able, to see how, from a planning stage, how they think, how they plan the case, and then just, try to translate everything using computer and then generate a guide for them. And I was able to see how the guide really works chairside. So that makes me, who I am today. So yeah, so like this is like a little quote for myself. So others show you what to do, and then now actually guide you there. So this is a little, overview of what we are going to talk about today. So we're gonna, slightly talk about what's the different type of guides and what is the basic, what is stackable guides, and there's maybe a different way to do conversion pickups, and then we're gonna do a live demonstration. And welcome to my world. And then we're gonna do full arch surgical planning, and then design a bone reduction guide, and then we're gonna design a stackable osteotomy guide stack on top of that. So before we start, this is majority three type of sky that we usually use. The first one is a tooth supported, basically just sits on the tooth, right, as a sitting jig. And the other one will be mucosa supported, which is a tissue borne, right, like that's a base plate or like a denture, right, it sits on the soft tissue only. And the other thing, like more surgical approach, is bone supported, meaning we flap the bone and then have this guy just sit on top of the bone, right? So that's basically three major way to do the guy. So this is the tooth supported guy. Looks like, so this is Dr. Camino. He's doing, like a single implant. So the most often time we use, basically we just, you can do it flap or flapless. That's really up to the clinicians. And then what we need to do, just a guy, and then sits on the teeth. He sits like just like a night guard, that type of thing, right? So you just sit in jig and then hold the guided sleeve in place, and then you drill through it. So that's basically how to supported guide works. And then the other thing would be tissue supported guide. So tissue supported guide basically it just sits on the tissue only, right? So this is the master model that we usually work on. So we'll decide a guide just sits on the tissue, basically like a base plate that per se, right? Just sit on top of that. So this type of guide you can do it as one or two. So two as here, the first one just a pin guide you sit on and then pin it. And the second one just sit, at the same position. And we use fixation pin to secure the exact same position for that. I mean, it's optional. You don't have to do that. Just a tissue borne that will do the job also. So, and then you do the drill through the guided sleeve. And then, yeah, this is how you proceed with, tissue supported guide. All right. So the last one is the bone supported guide, right? So basically, the guide is not sit on. So when the teeth and the soft tissue is not our best friend, and we can also still, there's another thing that we can go into the bone, right? We flap it, we see it, and then we can sit the guide right on top the bone. And then, yeah. So as for the accuracy, actually, the bone supported guide is the most accurate because if you were in my webinar before, you would know either soft tissue and tooth bone, they have to merge two files together, and whatever merge, there will be deviation, right? So bone supported guide itself, it doesn't require any merging. What you see is what you get, right? So the accuracy is very high as long as you decide the guy correctly and you flap the you do the full thickness flap where it should be correctly, and that accuracy is so high if everything is done correctly. And to do that actually is not that easy because we don't have the chance to take the impression on the bone. We don't, right? So we usually use a CT scan to generate an STL file from the bone. So to generate that bone, and then design on a guy on top of that STL file. So that is kind of tricky. I mean, the bone has to be STL file has to be accurate enough for you to proceed, right? So now so there will be T supported guy. So when we do for large cases, the tooth we have to take out the tooth, right? For sure. And then we have to reduce the bone to bone reduction, usually, in order for us to gain enough clearance for the prosthesis or gain more width for the implant itself, right? So when the tooth and mucosa and the bone is all gone, where is your guy gonna sit on, right? That's a challenging, right? Because all the reference point are all gone. So they actually people are, I mean, technology today is very, very nice. So people start to think about, hey, how about we can use this type of thing that called fixation pin. Actually, what it was originally designed for is to, when the guy sits down and you drill a little fixation hole and then use a pin to secure it, just lock it in place, right? So, so people think, oh, okay, so we that thing, I mean, will stay there during surgery. Right, so this is what you usually do. You put a guide on and you secure them. So those pins are actually our best friend when the tooth and mucosa and the bone are all gone, right? So basically, we use the teeth or the mucosa to, secure the position, and we use a fixation pin to lock it, and then we take out whatever you need to do, and then because that orange area is actually the bone supporting guide, or we can call it foundation guide, right? Because the pin is secure, it doesn't move, right? So that becomes a very solid reference point for us to rest another thing on. So that's actually how the stackable guide works, right? So the teeth, the bone, the soft tissue all gone, we still were able, the guide is still there, right? So the stackable guide, why do we need that? So it's actually a guide supported guide, right? The fourth type, right? I name it, but it is what it is, right? The guide supported the guide. So it's not only the three one, there's a fourth one is actually the guide supported guide, right? So this is kind of like how it works, right? So usually, I mean, you use a melting guide sits on either the teeth or the soft tissue before you do, the flap on the palatal or lingual, right? So before we do, we raise the flap on buccal because the bone reduction guide sits on bone, right? So that you have to flap that first and then use the melting guide to index the bone supported guide in place. And then you drill for fixation pins, right? This is the most critical part, right? After that, you can remove the melting guide. The melting guide has done its job, right? So now everything on top of that bone reduction guide, right, can go away without, the position, whatever is gonna be missing. You don't have to worry about that anymore, right? See, now you see, the bone, everything is all gone, but the stackable guide sits on the guide, right? The foundation. So it never changes its position because we kept it, right? And then after the pallet drill, you can just place your implant and then right attach the MUAs, right? And then you're ready to convert. So this is basically how a stackable guide works, right? So basically it start with the melting guide, and then you remove the melting guide, you can take out the teeth and remove the bone, and then stack with stackable, osteotomy guide, and then drill for implant, place your MUAs, and then if you try to do a guided conversion, that's also doable on the same foundation, right? We just stack it on. You plan where the prosthesis needs to go and carry it to the right position. There you go. So this is how how a stackable guide works. So naturally, and the stackable guide sounds like, I mean, okay. So I know how beneficial it is. Then how can we get there? So this is what we're gonna do today. So and actually, the very important thing is, whatever guy you make, there has to be a master model, right? So a great labware. I mean, it doesn't matter. It's a crown, a breed, a hybrid, or even guys, of course. So all the labware comes from a great master model. That's very important. So I'll show you, step by step how to make those master model and then make a guide on top of your master model. So let's jump right in to the live demo. Let me share my other screen here. All right. Okay. Okie dokie. So let's see. I think we're good to go. All right. So here is our patient today. We're gonna do a lower full arch practice on the patient, and then the patient is, you can see, this is, everything is, I mean, basically all gone, right? So it's only a, soft tissue is fully edentulous, maybe one leftover implant. It's not in, the best position. So we're gonna plan to take that out and then place some more implant for the patient. And then this is RealGUIDE software is really nice. I'll walk you through, how these things work. So before we start, of course, we're gonna, we use a dual scan on the patient. What a dual scan means is, we have the patient wear the denture and then do the scan, right? So what by this we will know, hey, where the teeth belong. That's the most important thing because everything we do here. So after all this year, I work with those three, phenomenal prosthodontists. The thing I picked up mostly is restoration driven because the patient come here. It's not for the implant. It's for the teeth, right? So we're gonna know where the teeth belong, right? So to use, the denture, I mean, carries a majority three important message for us. First is where the teeth belong in the, space, right? The midline, the can, the arch form, all that, right? The other thing, you will also carry the intaglio side of the patient, basically the soft tissue, information, right? And if you have a double arch, which is the patient right here now, you will also have the jaw relation, Right. So this is beautiful. So it's you can see here. So we do a double scan, a dual scan on the patient, right? And then yeah, I mean, so we have the occlusion, and then the good thing is, we can generate a soft tissue model, right? After the dual scan, we can use real guide to cut the ridge, and then flip it, and then you just become a soft tissue model right there in the same scan. So a dual scan give you where the teeth belong and give you where the soft tissue belong. And then we're gonna use the soft tissue to see the guide on, right? The bounding guide, right? And then the other thing is it's gonna guide us to where the implant should go. And do we have enough clearance? Do we need to create more space by reducing the bone for the implant processes, right? So this is very, very important message that a denture could give us, right? Super important. So in order for us to save some time, I already placed for implant here. So let's look at that. So this is I placed one at number 19. So this one we use a Zinvi implant, which is a very good implant. And then we can also, we know the soft tissue in the crown, right? So we can kind of measure, hey, from the occlusal table to the soft tissue is about 10. So to the implant level, we are about like 11.5 to 12-ish. So this should be a good amount of, restoration space for, full zirconia bridge, that per se, right? Or I mean, if you want to do a like acrylic wraparound, maybe it's up to 15. So you can see, okay, if you want to do a 15, so the implant might have to go lower, right? So you will know, right, before you place the implant. So you won't know until restore the patient. That's not gonna be a good day, right? So that's clean this one. All right, so the next implant I place it at like somewhere like 23 area. So we can, also do another measurement at the anterior. So you can click on this implant and real guy is very good. You click into that implant, so you will rotate 360 around the implant. So you'll see, oh, there's a bone defect. Okay, should I run away from that? Or what, right? So we can do another measurement here. We're about like more than enough at the interior. That's awesome. All right, so that's clear that. So let's check out this next implant will be number 26 area, which is right here. So we are kind of like, looking for the backbone. So we're in, between cortical. That's great, right? And then, yeah. Let's move on to the next one, number 30. Let's see. Yeah, I mean, the bone is, just good enough. So we have the, the implant sizes there already. So let's look around. Yeah. And what about the video? We're about 11.5, exactly the same. That's beautiful. All right, so that's basically with it, and then we can check the AP spread. AP spread stand for anterior posterior spread, right? So we can at least, restore the fixed bridge to the molar to molar with zero cantilever, which is amazing. And you also have the chance, to I mean, we have very long AP, so it will be no problem to add second molar if needed, right? So yeah, and then the parallelism, so you can do here. So that's we can click here, show implant angles. So this is like very very nice feature. You can set one as a master alignment, and you can set parallel if needed. Let's say you try to make a conversion denture with the hole, that will be very beneficial. Or you're designing a, let's say, locator of an denture, the parallelism between each between implant will be pretty important also. So that will be just click on step out parallel, you'll be fine. So we are all parallel here, which is amazing. And then we can either click on the info here. Okay, we see the size for 113 anteriorly, good for 7 by 10 posteriorly, good. And then let's see on the panel view, let's look very symmetrical. I mean, you don't have to be symmetrical, right? But you have the chance to do the planning. I mean, why not like make it like beautiful, right? I mean, just you know, we have that chance, during surgery. It's not that easy to achieve this, but with guided surgery, you have time, to, manipulate slowly here, before you really move on to the surgery. So, all right. So I think we're good to go here. So, and then with that, being done, let's see how if you click here, you can see the bone. So if we want to do that, okay, we might need to, reduce this amount of bone, right? As you can see, I also already attached the sleeve. So this is the DAS sleeve. So how to do that? You can, click change. So RealGUIDE is a, universal system. So you can select whatever sleeve you want to work with every, different, implant system. So you can just, click here, show all, and then select dynamic abutment sleeve, right? And then click that. So this sleeve can work with all the implant different system, which is amazing, right? So you can just select that. So that's the dash guide sleeve just been selected. And then let's hit apply. And then now you see, okay, with that, insertion depth, let's put a soft tissue on. You can see, uh-oh, we have issue here, meaning the sleeve is hitting the soft tissue. We saw it's gonna be an issue, right? The tissue is the issue. I love that quote. And then yeah, so we can simply just raise the sleeve, but since we're gonna do a stackable here, there's an easier, solution to making the guy here, which I'll show you later. So this sleeve doesn't hit anything, they're good. This doesn't hit anything, they're good. So those two reds, they're actually hitting, the soft tissue, not only, but also the bone somehow, right? If you can see from this view also, so you can tell you and yeah, it might not fit, right? Not to mention the soft tissue, it's gonna collision right there, right? So yeah, you can, simply raise the sleeve because, that guided system allow you to have that freedom to do so. That's super easy also. But we can do another, stackable guy. Like we can, flap the tissue and reduce the bone and the sleeve can stay where they should be. That's amazing. All right, cool. So how to do that? So before we do so, we need to define where is the bone reduction profile or the reduction plane, right? So to do that, there's another function right here. If you look here, so this is only shows on it's called Sandbox, right? The Sandbox, the name you can see. Oh my God, this is a playground for any cat can designers. Oh my God, this place is amazing, right? So the sandbox is actually where real guy shines, I would say, right? So if you go into the sandbox, you can basically do anything you want to the guide design, and I'll show you how they apply to stackable guys. So before we do, we have to cut the bone, right? So in this software, it doesn't come with a bone cut, profile. It doesn't come with that. So we have to use another function, that function called volume splitting, meaning we're gonna create a space, and then that space is gonna cut away different object. Yeah, after I run all this, you will know, oh, okay, this is how that works. So before we do, I already generate a STL file, which is the segmentation for the bone. And this is another very, nice feature that, RealGUIDE offers. It just one click on the AI, it would just generate a bone for you. How cool is that, right? So before we proceed, actually, I would like to do duplicate on the model, right? Just in case, we need to do any adjustment, go back, whatever, right? So we need to do a cut right there, right? So we're gonna use volume splitting right there. So the volume splitting right tool is actually a let's say a box in a space, So what they do is, you just click on the box. Let me see here. Really click that. So you see those, yellow dots. You can drop those dots and then you will, create a box there, right? So the box, and you can drag it, up and down like that. Let me move back can force a little bit like that, right? I mean, you can change the angulation, right? Or you can change the height, you know. Usually you try to aim for that, implant platform because that's where the bone has to be reduced to, right? So yeah, I think this is pretty much a good position, for the bone reduction. So we're gonna cut the bone along this plan, and if you're happy with the box, just hit next, and then just hit here, subtract selected slot, right? So that slot is gonna divide this file by two. So in the software, but in the reality, what we just do, we just, in digital world, we just split those two files. But in reality, this is, the bone reduction itself. How cool is that, right? So after we reduce this bone, see this sleeve is not hitting anything, right? Beautiful. So what we need to do is to create a jig to hold this sleeve and actually design a base, right? The bone supported guide, right? Foundation guide, and then create some sleeve cylinder to hold this sleeve, and then use that stack on a foundation guide, and then we can make the stackable guide beautifully. All right, so that's the first step that we just done, which is the bone splitting. And then we also it's not only we cut away the bone, we're gonna use exact the same slot to cut whatever guy is gonna come after. And I'll show you real quick. So let's finalize that. So we just came out from Sandbox. So as you see here on the left side, oh the left side here is just different modules, for real guys. Yeah, I mean in the very first time you see so many buttons, so many windows. There's CD scan, STL files everywhere. I mean, don't be scared. I mean, in the very first beginning phase, it was like that, right? I mean, it's not that easy to get started, but once you get used to it, okay, oh, this is the step that need to, be done. So basically, you just follow the flow, like right from the beginning and all the way that we were in implant stage right here. So basically, you just some data, orientation to crop the image, and then just import all your STL file. This part is critical, by the way. And then just draw your, panoramic curve, and then do your wax up, and then implant planning, right? Basically just like that. So whatever comes after that is, for the sandbox, and then for the guide design is comes after that, right? So once the implant been placed, and then we decide, I mean, we plan where the bone reduction profile, the plan has to be. The next step is to design a bone reduction guide to cut that, bone into that position. So to do that, we have to, generate first our master model. So I already create a master model here. So this model here is, merged by the soft tissue itself and the bone, right? So two in one. So we can, decide whatever guy is gonna sit on top of this. So this is our gonna be our master model. And yeah, this is another important thing I almost forgot before we, move forward to the guide design. There's a hero behind the thing, which is those fixation pins. So fixation pin, we already run over, how important they are, so we have to plan this, fixation pin in place like carefully. And then because, the position for that will not only affect, the stability of the foundation guide, it also affect, if it's gonna fit in the patient's mouth. What I mean by that is, okay, I'm gonna plan this, fixation pin like that angle. Yeah, I mean, yeah, digitally, is, doable. I mean, you can do anything in the digital world, right? But we're working on a real patient right now. I mean, if you turn on the, soft tissue, I mean, if the fixation pin stay there, you think, I mean, and you have to feed your, handpiece that angle and end up a, height for the handpiece, you think that drill is gonna work? I don't think so, right? So that's another challenging thing. So you have to, I have to think about it. And like usually, the angulation for the fixation pin will be, better, from the top and then angle down. That's, easier access for, for the fixation pin because place them is not that easy. And also, the how distal your fixation pin should go is, the more distal because we're gonna design a stackable guide on this, right? So ideally, our AP spread on the foundation guide, right, should be good, should be as far as possible, right? So if that's the case, let's see. Okay, I'm gonna do the fiction guide super stable. We should stay let's say around the implant. And then we're gonna, not that close, but you get the idea, right? And then we're gonna maybe even further, I can place it there. So it's gonna AP spread, that's super A and super P. And then you have a super long, bone reduction guy, and then stackable guy on top of it is gonna be super stable. Theoretically, yes, but in on the reality, I mean, can you really fit a fixation pin in such place? Right. So you have to think about there's a chick, there's the will be done and everything is your enemy. I mean, during surgery. So you're gonna factor that in also. So usually the rule of thumb, so where to place, the fixation pin will be between, within that's say mental frame, and that should be pretty much safe place, to fit everything in so the lip can be retract, and then you can kind of like, turn on the soft tissue model. You can mimic, okay, when the lips being retract from the by the fixation pin, is that doable? I think, yeah, we're at the corner of the lip should do the job, right? So this is very useful, right? The soft tissue model to help you to visualize if your fixation pin position makes sense. And then this is another thing I learned from Dr. Scott Gans. He said he spent exact the same time, not exact, but almost the same amount of time on fixation pin and to the implant same time, meaning this is a very important thing. So the position matters. The other thing is the stability matters also. So what do I mean by stability? So you have to look at the bone to see the density is good enough, and then the volume, which is how far you traveled into the bone, matters also. So let's see. We coming from here to the where like more than, so the rule of thumb will be more than four will be the good number to go. So we got six right here, and the bone density looks pretty good, and we're kind of like, bi cortical-ish right there, right? So this fixation pin will be like very nice. And then I see the other one. Yeah, this one is mean bicortical right there, right? So we can see we stay away from any vital, anatomical structures. Okay, this one sits on a bone defect, but this, bone volume, density right there looks very good. And then yeah, and there's another implant right there. You don't want to, mess around too much. So I would say that should be a good, you know, position. So as a, lab tech, actually the fixation pin's position is more important than the implant itself. I mean, designing wise, right? Because you want the AP spread, to go as far as possible, but you don't want to go too far, and you want the, angle from, let's say, sagittal view, like coming from up to down. And also you look at your bone reduction profile, you want everything stay below that, because whatever gonna stay on top of it is gonna be cut away, right? Or the sleeve, or I mean the cylinder holds the sleeve will get in your way when you do your bone reduction, right? So many things to think about, right? So the fixation pin plays critical rules, right? Even though, it does never shows up on panel, post-op, you never saw that, but this is the true hero behind the scene, those fixation pins. All right, let's just say we're happy with the position. Then we can move forward with, the bone supported guide. So the bone guide, the bone model is right here. So this is a guide design. So that's heat. We can let me see. All right. So let's just create a new one, and then let's go. Oh, right. So the first thing, this actually confused me in the very first time, right? So is the sleeve. I cannot see the sleeve. I cannot do the designing though. So okay, so the sleeve, if you toggle here, so you will show the sleeve, okay? And then as you see the green line here, if you don't want this sleeve, happen to be designed within the guide, you click them, make them, on highlighted like that. So we don't need to do osteotomy right now. We just need those fixation pin. So those sleeve was for that pin sleeve. So we're gonna use that. And then yeah, so that's our basic guys gonna design. And actually I forgot a very important step, which is right here. We're gonna select our master model. So let's do that. And then to the guide side, create new guide. Do you want to use the processes? No. All right. So that's what I made a mistake right there. So okay. So let's use that. And then the first step is to generate, select a base model, the master model, which is this one. And we're gonna define the path of insertion, right? Super important for any removable appliances. So we're gonna see, so you don't want the guy to see like that because we're gonna create undercut on the bone side. So we need to see the bone, right? We don't want it going from here or there. We're gonna go from, depth center, something like that. And then we can hit set insertion from the views. So the path of insertion is gonna go this way, right? So that's gonna be all the undercut, right? So we can see all the bone, is within the survey line. So it shows everywhere, right? So we can hit generate undercut. So what does that mean by generate undercut? You will see real quick. So that's a good thing about digital, tools. You will just black out any undercut so you won't get caught, right? So this is the undercut, right? You just, generate undercut to block whatever, right? So this is actually the master model for the bone reduction guy right now. So because we just chop that bone, right? So we can turn it on. We can see, okay, that's the bone reduction profile. And then we can turn the sleeve on. Okay, that looks good. So we can hit next. So we can now start to design the bone reduction guide. So the bone reduction guide usually can go, either buccal or lingual side, but we found it's just easier to design the bone reduction guide at a facial or buccal because you don't have to flap at the lingual or palatal. That's harder, right? And then you don't have to worry about seeing the guy from the occlusal view. So you're kind of missing some spot on facial, right? So we have the privilege to see the guy like from the facial. That's easier, right? So we're gonna do that. So usually when we design a guy, the width for the bone reduction guy usually would be good to be 4 meter. I mean, at least 3 millimeter. Ideally, you look for four. Okay, so that's my thickness gonna be. So I'm gonna drop some dots. Look, my 4 millimeter guy, and this is a mental framing. So yeah, you don't want to mess around with that. So never set your support there. Okay, that is not fun. All right, cool. And then we gonna set the guy. So this is on the car, so you just pass through. So I'm gonna just use that measurement. So that's four there. Now you can see how easy it is to, to design the guy using the parameter. So we're gonna check again. So here is kind of short. So we're gonna increase that a little bit more. And then yeah, let's use that 4 millimeter to see around. So yeah, so the other take home message was yeah, the wider the support area it is, the more stable it is. But when it comes to bone supported guy, and that means that greater area of flat has to be raised. So you have to factor that all in, right? I mean, I can design, the support all the way to the chin, right? It's gonna be super stable. But who's gonna do that flap though? Right? So, right, we could do it, but don't do that. All right. This is it's not gonna be fun during surgery. So we're gonna, stay, just enough area for us to land. And then, but still, try to make the surgery more minimum invasive, right? That's pretty much pretty critical also. And then, yeah, so, and the parameter here is actually, matters also, but we're gonna, in order for us to save some time, I'm kind of running bit a little delay, so they just hit gray guy for now. But actually, those offset, to the bone, to the teeth, to the soft tissue, the offset should be different, And yeah, if you are interested in that, just feel free to reach out to me afterwards. So we're gonna skip that for now, and then yeah. And so we can basically move forward. So you can see this area is kind of wider, right? We don't need that, right? So the other thing, in Real Guide, what is really good is, you can use the scope tool, basically like a, your handpiece, right? Digitally handpiece. You can just cut it away. How cool is that, right? So we can, just, manipulate, the design of the guy, free. I mean, yeah. So using Railgun, you really have that total freedom to customize all your, designs, even, do some, touches, add material or reduce, right? Okay, I think we're good for now. So yeah, you're thinking, hey, David, that bone reduction guy should be flat, right? How come your bone reduction guy is up and down? It's not even. Are we gonna follow that to do the bone reduction? No, right? So this is how the Sandbox, the split file works, and I'm gonna show you how to make that exact the same position to make the bone cut. So let's go back to our playground, the Sandbox, and then let's find that. Um, Let's save the file for now, just in case, any digital thing you don't want to crash. All right. So the thing is, we're gonna use volume splitting tool. So this is exact the same position where we cut the bone, right? So we don't need to cut the bone right now, but we're gonna cut the bone reduction guide instead. All right. So we're gonna cut it here. So you think, yeah, that should be good. And then if you want to edit it, you can still do it. I mean, by bringing the dots back. If you think that cut is kind of too much, you want to keep some, at a supporting art, and then that should do the job. And then let's hit next, and then subtract at, so this bone reduction guy has just been subtract with the exact the same slot. So this part, we just remove it, right? And then let's go finalize this. Alrighty. Okay, so we're back. So we don't need this part anymore. Let's just go ahead, delete that. And then now you can see this bone reduction guy has just been, cut to where the bone reduction plan is. Beautiful, right? So this is how first chop the bone, and then second, do the bone reduction profile designing, to where they should be, right? So this is where we, cut the bone and the implant. Beautiful. So this is how bone reduction guy buckle only, how's it being made, right? So we just design that, which is good. All right. So the next thing is we're gonna design a stackable guide sits on top of that, bone reduction guide, the base, right? So the first thing we're gonna do, we're gonna generate, the cylinder around the sleeve, just using the guide supporting tool. which I should save some time. I already done this part already. So you just, select your sleeve and then in the space, and then just, use your scope tool to reduce whatever you don't need because the cylinder is all we need, right? So now after that cylinder, the osteotomy guide, the foundation is right there. So we can go ahead to design the stackable guy. So yeah, I mean, in the digital world, they will kept their position at where it should be exactly. But in the reality, when you print this out, I mean, those donuts just fly everywhere. No good, right? So we're gonna design something to lick them up. So there is another tool in the sandbox. Okay, let's go back to the playground again. All right. So as you can see, right, there's so many freedom that you can do in Real Guy, right? So what we're gonna do here is to create a custom bar to connect them, right? So before we do, I mean, you can do square, you can do circle, you can do ellipse, just up to you, right? So I usually like circle, and then I like to use a little bit thicker, like, 4 in diameter or 4 5, it's up to you. Doesn't really that matter. As long as it's, greater than 3, I think we're fine. All right, so just drop those dots, right? And then we can connect them, digitally, right? So before when you do this part is a very important message. Tricky part is, when you drag this, never drag this into your cylinder. If you do so, your guided sleeve will not fit during fabrication, right? That makes sense, right? So just never make that happen. Just, oops, just, something like that. I would do the job. And then you can hit create bar. So we just connect those two. And then we can do another bar. Let's click a new one. And then let's connect them like wherever you like. Okay. All right. So I'll say that should do the job also. And then let's hit create bar. And then, yeah, we're basically there. But in a digital world, when we print this out, if we just, show this, that could be a little fragile. So I'd like to, design different bars to connect all of them. So what I'm gonna do here, I'll create another one here and then try to go a little, diagonal. And then, yeah. So there's another thing really interesting, tool here. You can drag wherever you want it to be. All right. Anybody like spaghetti? Right? This is so nice tool. I mean, so much freedom. So we can connect, them. I mean, the way we want it, right? Even the height could be, to change accordingly. So it really, really, really is, up to you. So where, to land those bars. So I like to, had the bar just pass through the geometry center of that, guide. So you just need one finger to press on it, so it will stay very stable, if that makes sense. All right, so that's that. So that's hit create bar, and then we're gonna do the other thing on the other side with the same mentality, and then that's drag to connect all them. Alrighty. All right. I think we're pretty much there. Yeah, just a little bit. All right, cool. So this is the base, of that how to connect those cylinders. So that's hit merge all visible bars. So because we just create 3 4 bars, right? If we click here, it will just merge all the bar into one STL file. So you will able to see that right here. Sorry, I just need to create a very last one, and then we merge everything. Okay, so that's the merge that we worked. All right. So I think we didn't touch any, sleeves, and then they are all connected and looks, stable enough. So I think we can move forward to end this tour. And then the next thing, because they are still, two separate, files, we're gonna merge them into two, right? So we still want to stay within Sandbox, our playground, right? This is like a Boolean operation. So this is just basically add to the way doing math we using a 3D object. So what I mean by that Boolean operation is we're gonna add things together and merge them into one, or we can subtract object, right? So what we do here, we can click that. Oh my God, I got a bunch of stuff. All right, never mind. So let's see, we're gonna click that merge the bar. Let's see. Oh my God, we got so many, many objects right here. So merge bar number three, that's that, right? Should be it, right? Okay. So, and then just hit apply, and then they will just merge into one file, which is right here, right? So this is, the one file right here. So we have, the osteotomy guide already made. And then let's see the time. Okay. So the next thing is, yeah, so the guys here, and then we have that bone reduction guy. So, hey, then we got two guys. How are they gonna stick together though? And don't worry, we're still in the playground. So the playground is another very, very nice feature, which is the connectors. So we can use those connectors to connect different STL file in a same relation and kept their relationship. So that connector is right here. That's hit add connections. If you hit that, there will be different module to select from. So yeah, in order for it to save down time, so I already design those connector. So you see those connector, they can change the size and then change its position, which is great. Even rotation, all that, right? And then you can even change the size of it, right? I mean, this is the size of it, right? Fancy, right? So you can, position where you want it to be, and then just make sure all that, connectors, touch the two objects correctly. So here we might have some issue, and I'll show you what I mean by that. So this right here means no issue because all the material covered, the connected bar. But here, because the material here is like kind of a little pass through that bar bone reduction guys, so there will be extra material there which we don't want, and I'll show you how that really work. And then the other thing is, so this connectors is actually a tube and a hole that fits together. So because there's multi units of the connectors, so you are gonna know what going to say is the path of insertion between all of them has to be mean parallel. If they are not, you're gonna have a hard time to fit, the stackable guide. So good thing is there's function here, just align everything from the view. So basically you just want to see, okay, where's the perfect view there, and just hit that button. Everybody just whoop, align to the same direction, and you won't have any problem doing so. All right. So yeah, so because real guy provide us bunch of freedoms, but freedom comes with cost, which is too much freedom. We might run into some issues because we design something that doesn't shouldn't exist, right? So we're gonna watch out for that still, even though we're sharing how to do it now. But I mean, if it is the very first time you're doing this, don't do it on a real patient. I mean, just print the model out and try to play with it and print your guide out and to see how that work together. Just make sure you work on the model and then you might proceed, to see how things goes on the real case. All right. So let's just hit next. So what the software we're gonna do, if we hit apply, so the connector just gonna, connect to the upper, to the to the drill guide and to the bone reduction guide separately, and then make them do another Boolean operation to make them merge as one single file. How cool is that? So we can see this file right here. So this is the whole, right? So as you can see from this view, this is all parallel, right? And then we stack on top of that. And then I see the parallel, right? See? So this is, how easy it is. We can design the stackable guy, right? So yeah, this we can even, change different, let's just hit end tool and then we're back to the, sandbox, and you can even change different colors, as you like, right? I mean, beautiful, right? So there's another thing I want to point out, which is, this material right here. If you doesn't pay attention, to those details, this guy is not gonna fit, right? So let me show you why. So if you put a bone model back in, you can see there's an issue there, right? I mean, okay, it's hitting the bone. So it's not gonna work, right? So other than that, I think we're good. So we can either, do some toggle the transparency for them. Yeah, so this is the only issue we're looking at, and then the other should be fine. Yeah, so yeah, just be careful when you design a patient still with the teeth, right? Like sometimes the teeth stay on the buckle a lot. When the surgeon wiggle the teeth, you know, the guy might stop the teeth from going out, or even it will rock the guy and become loose and change his position. They're very dangerous. Like that type of thing has to play come into your consideration. So to avoid that, so usually I'll just design the guy away a little away from the tooth that's really protruding out from the buckle, usually the canine, right? That's what was the major nightmare, for the tooth extraction. So how are we gonna fix that, right? So we are at this position again. So either we can go back, design the bone reduction guide to make it longer to cover everything, so this part won't get protruded, right? So because what I mean by that, so if it's all wrapped it, the software won't allow the other side to go into that other side, but this right here doesn't work, right? So we have to make that work. So still, there's another very good function in the real guy is we can add it, the guy however we want, right? So we can, either, turn on the boom, okay, we don't need this part. We need to cut it out, right? So they will cut by area, right? Then just select that and then select it and then he cut, boom, done. Not yet. All right. You get the idea, right? So we can cut from different area and then yeah, and we can either toggle the transparency. Okay, let's see. Okay, we still have some issue, and we can use some freeform tool. This is my favorite. Okay, this is smooth tool. Look at that. Oh, right. Just reduce those excess, additional like material, and then you can even smooth this out, right? How cool is that? And then yeah, so we're away from that. And then if you're concerned about this, you can also do that also. And then there you go. Issue fixed. And if you want, yeah, I would do this usually just, to make the guy, look even better. And then, yeah, just want to show you the function. Not only can, smooth the whatever um surface, you can either, add some material, right? But just be careful, don't add it here, right? no fun, right? Don't do that. All right. So you can add it or you can reduce it. Just want to show you how the, real guide could work. So you have those freedom to really to form the, your guide design, which is great, right? And then, yeah, just be careful, just design it correctly. That's very important. All right. So basically we can finalize this. So let's wrap this up. And then let's go back to the major designing area. All right, so after finalizes it, we'll exit, the sandbox, and then we can see our, outcomes. So we can see our bone after the reduction, right? And then that's the first guide, and this is the actual, osteotomy guide that we designed, and then you will have no problem because it doesn't touch anybody. Cool. And then yeah, we can just, use the stackable, I mean the bone reduction guide and then secure them. So this sleeve is designed with DAS guided system also. So they come with a guided sleeve also, fixation sleeve and pins also. And then secure the bone reduction guide, reduce the bone, and then stack with the osteotomy guide that we just designed, right? We use the custom bar to connect all them, and then use the connector to connect different, two objects together, and then we can finish, the, osteotomy pretty easily, right? Okay, so that's basically what we let's go back to the let me see. Let's share content here. And then let's go back to our keynote. So that's basically the how we design, a stackable osteotomy guide and a bone reduction guide together. And then I'm gonna show you how. So this is actually a real case. So this case, I work with Dr. Sampal Benchurit, which is amazing, amazing prosthodontist. And then he just, proceed with the surgery that done with this software with the same approach. And I want to show you how that, being done. All right, so this is exact the same patient that we just worked on. All right, so we'll look at the bone. So this is the planning stages that we just shared already, right? So we design different guides on that. And basically the same approach. And then this is, the guy has been made. We actually, this is double large case. So as you can see, this is the guy that we just, the exact same one that we just designed, right? And then the only difference just, they are, double arches. So that's ready to proceed. And this guy was fabricated by real-time dental lab. And then we were in high point and ready for the surgery. All right, so we use the first one, the mounting guide, to use the soft tissue and the existing implant to position. We check the fit, and then Dr. Benchray just do the flap at buck. Then we check the fit on the bone reduction guide. Is it gonna fit good? All right, no problem. And we use the mounting guide, to mount the bone reduction guide in place using fixation pins. And then we drill it, pin it, and then we can now remove the mounting portion. All right, so we remove that. So now it's time to reduce the bone to where it should be. We create enough clearance for the prosthesis. All right, so this is the stackable drill guide that we just designed to get it. All right. And then we use the guided drill, the drill for osteotomy. All right, and of course you can place those implants through the guide also. Righty, yeah. So implant placed, and yeah. So yeah, we just do that, and yeah, we remove that. Everything's within the bone. It's beautiful. We suture that, and then we do another surgery on the upper. Same approach, same thing. Bone reduction guide, pin in, and then reduce the bone and stack with stackable. Drill guide, same thing right there. And then yeah, that's the surgery of a double arch, guided approach. So a little wrap up today. So we ring over different type of guides, and then what's the basic? What is stackable guide for, and why do we do that, right? And then we do the live demonstration of full arch surgical planning, bone reduction guide design, and then stackable osteotomy guide design, right? So yeah, I was calling for cases. So we are gonna do this type of webinar as a monthly basis. So if you would, you can, send your cases to the email below. So if you want to talk about it, want to discuss it about it, just email to me, and then we can start it and learn all the cases together and having some discussion, right? So if you want to reach out, please, if you have some questions, any comments, any suggestions, this is my contact information, and if you would, you can follow me on the social media so we can all have, had a, guided surgery fun all together. All right. Thank you so much for joining me tonight for the webinar. And I thank you so much. And this cold day and winter day, and there should be another, snow coming in, right? So stay warm, stay safe, So thank you guys so much for being here today. So I will see you in the next webinar. Thank you. Goodbye.